Okay, there we go. We started recording now. All right, so during last week's recorded lectures, I asked that you bring something with you, not drugs, but questions about drugs. Before I kind of just open this up, that we can talk about anything, I do want to, again, kind of make this observation that we made about sleep, reminding you that one of the arguments I'm making is that how your brain interprets information need not match reality as long as it enhances survival. I want to make that same argument for drugs. So let's just review for a second. How do stimulants alter perception? Just as a class of drugs, how do they alter perception?
They kind of increase activity.
Right.
So you're like able to take in more than you normally would.
Yeah, it's going to increase the activity of the nervous system. And really what part of the nervous system it increases activity in is going to determine how the perception is altered, right? So for most people, that perception, more activity means greater awareness. It means kind of activation of your sympathetic nervous system, the fight or flight response, heart racing, perspiration, blood rushing to your extremities, and your cheeks get flush and your pupils dilate, those kinds of things. So generally, that's what you're going to see. So what the perception we're altering is you're more aware, you're potentially more focused, etc. How do depressants alter perception?
Don't they do the opposite? They slow everything down?
They slow everything down. What that really means is they inhibit certain parts of the nervous system. So in the case of alcohol, we are inhibiting certain parts of the frontal lobe, which are in control of decision making and certain aspects of personality. So when you drink alcohol, you are inhibiting the part of your brain that inhibits you, right? That keeps you from making a fool of yourself at a party, or that stops you from acting on aggressive impulses that you might have. But generally, it's going to slow you down. It's going to make the world seem a little bit, I don't know. I think the first time that I drank alcohol, I was really nerdy about it, and I wanted to see what effect it had on my perception, on my body. And so I was kind of like waving my hand in front of my face. And I don't know if I can appreciate this level of detail anymore, because I think once you get used to alcohol, it just doesn't. You don't experience it the same way anymore. But my hands seem to kind of have an after image, right? Where you can kind of like, if you wave it really quickly, you can kind of see almost like a trailing of the visual. I noticed that, and that's a symptom of a nervous system slowing down, of kind of not updating as quickly as it otherwise would. So yes, and then hallucinogens do what? How do they alter perception?
They make things exist that don't. Like your brain thinks there's something there, but there really isn't.
Good. Yeah, that's a good way of putting it. It makes something exist, or at least you see that it exists. You think that it exists, but it actually doesn't. So your brain is going to put patterns together that don't actually exist. Those could be visual patterns, auditory patterns. You perceive an object or something that is not actually there. Okay, here's the million-dollar question then. I'm arguing that if these things aid your survival, it doesn't matter if your perception is altered or it doesn't match reality. When you're on a stimulant, you're probably more focused, more aware of certain things than you would normally be aware of. And so to some degree, you could notice your perception is going to actually be a little bit more maybe expanded in some way. You're focusing on something that, or in the case of stimulating your sympathetic nervous system, your heart racing and your muscles kind of ready to go to action. That is normally something that activates when you are fearful, when you are afraid of something, or you need to act. When you take a stimulant, your body's going to think that it's time to act, even if it necessarily isn't. For example, I worked at Dunkin' Donuts before I went off to college, and every work shift, I'd work like 12-hour shifts on like the weekend each day, and I would end up drinking like an iced latte to keep going. And I remember after I would get off of work, because I would drink these iced lattes and there's just so much caffeine in there. I remember going home, I'd be deadbeat tired. My body would be wired, I'd be so jittery. My body thought that there was something to respond to because it was hyped up. Was there actually something to respond to? No. So my perception, the body's perception, did not match what my reality actually was, which was it's time to sleep. So let's think about this. How might altering your perception in each of these ways actually aid in your survival? Can stimulants, depressants, and hallucinogens, they've been around forever. Humans continually take these things. How do they aid our survival? How do stimulants aid our survival? Potentially.
I mean, you said it makes you hyper aware.
Mm-hmm. Which can kind of do what for us? I mean, why take a stimulant? Why be hyper aware?
What's your definition of survival in this situation?
Just your body's ability to get something done that it needs to get done or it wants to get done. That is doing something that will ultimately lead to a favorable outcome.
Okay, so like let's just say some people might take like a stimulant. What is it Adderall? Is that like a stimulant?
Yeah, it's a partly amphetamine, yeah.
It's known that some college students will take a stimulant like Adderall so that they can sit and do more work like in their classes and get it done and focus better.
Right. So we take drugs to alter our nervous system in a way that we at least think we need to, right? If you feel that you are incapable of focusing or that your attention tends to be split between many different things, Adderall can help you kind of focus in a little bit. Yeah, that's a good example. Same with caffeine. People drink coffee because otherwise they feel they wouldn't have enough energy to keep going, or they smoke because it not only stimulates but also somewhat calms you as well. Why alcohol? Why do you think alcohol is just so, I mean, it's a depressant, it's going to slow you down, and we know that to a great degree it can be toxic to you, especially in greater quantities. So why continue to use alcohol? Why do people drink it? What might be the survival value of alcohol?
Well, it causes the increase of releasing dopamine, so it's kind of necessary for some people. You could go crazy if you're, let's just say, I don't know, upset for too long, because some people don't produce enough dopamine on their own.
Okay, so it could be that if you are feeling down, you are low mood, that somehow alcohol will actually help you out of that. That can be true. Alcohol actually usually has. I will recommend this. Anyone who drinks alcohol to comfort themselves, what it'll often do is it might reduce your anxiety to the extent that anxiety is an overactivation of certain neurons. So sure, you could argue that alcohol would slow you down in that regard. Yeah. Another good example is I think people drink alcohol when they're at parties, when they want to. I mean, when you're at a party, you want to interact with people, you want to be fun, you want to be outgoing. So I think people end up drinking alcohol because it may help them flirt with the person that they are otherwise too nervous to flirt with, or to do the thing that they are otherwise too afraid to do. And so this is kind of a weird way of looking at drug use, but I think this helps because you have to remember that there is an appeal to drug use. There's a reason that it has continually been something that humans use and also struggle with. When you use a drug, it seems to help you out in some way. And then there's that kind of fine line between it helping you and then you becoming dependent to use it. In which case, what was once helpful now becomes almost like a handicap, right? You now depend on this in a way that probably makes your life potentially harder than when you first started taking it. So I think this is a helpful perspective, seeing that there is something that people get from using a drug. and to appreciate the power of how it can actually aid people in their day-to-day life. Okay, so I kind of just want to skip to this now. Savannah, you're the only one here. Are there any general questions about drugs that were not addressed in lecture, or that you wanted me to explain further, or anything that you kind of want me to give my thoughts on? I'm happy to do that now.
So, what made the PCP more addictive hallucinogen?
Because it has depressant properties, so it's not just a hallucinogen.
So it's a mixture.
Yeah, so it's the same reason that alcohol or certain types of opioids or tranquilizers would be addictive. Is often what they do is they rid anxiety, so they're depressing the system. You will feel less anxious, you'll feel more sleepy, and lower anxiety and sleepiness can be a pleasurable state. So this is going to be a hallucinogen mixed with a depressant. Therefore, you can become dependent on the depressant part, at least physically dependent on the depressant part, but not necessarily the hallucinogenic part. Though I will say this, hallucinogens, although some of them have very weak physically addictive properties, they can still have really powerful psychologically addictive properties. So when I say that LSD, you can't really become physically addicted to it, you can still turn using LSD into a habit, such that you think that, for example, I know for a lot of people who do computer programming, a lot of people might drop acid and then they will do computer programming. And they might think that after a while, their computer programming just isn't as good, or they can't do it unless they're dropping acid while they do it, or microdosing, as it's called. That would be a psychological dependence. You believe that you need it to do this, to do whatever you need to do, even though you're not physically dependent on it. Question.
I guess another one would be more, I guess, sleep medicine. What does that exactly affect? Like, not just like the melatonin that they'll give you, but if you go into one that's a little bit stronger, what does that do to make you sleepy?
Well, melatonin is really just the hormone that affects the other parts of your brain that tell the rest of the other parts of your brain to start putting you to sleep. A lot of arousal, sleep and arousal, is controlled by the pons, that really basic thing in your brainstem. I don't know all the exact pathways that sleep medicine will affect, but that is the part of the brain that's going to be most directly affected. That and the hypothalamus. The hypothalamus has a lot of its fingers and a little bit of everything, and the hypothalamus is part responsible for sleep regulation. So hypothalamus and the pons are those most directly affected. And so it's really kind of bypassing that whole melatonin system. It's bypassing it and just going straight to the source. What do I need to inhibit in order for you to feel less aroused and therefore sink into sleep? Pons is pretty much continually sending signals into your brain saying, hey, it's still daytime. It's still, there's still stuff to do, so stay awake. And then when it gets darker and it's getting those signals from melatonin, that's when the pon goes, okay, now we can start resting and relaxing and shutting things down. So with sleep medicine, you're telling that part of your brain, just shut down now. Don't wait for light. Don't wait for all these other cues of I should fall asleep. Just, start shutting the system down now. And so depending on how strong the sleep meds are, for example, a minor tranquilizer or something like Xanax, that affects a number of pathways beyond just sleep, but that might kind of make you sleepier but not put you to sleep unless you decide you want to go to sleep. Something like a major tranquilizer, that'll put you to sleep whether you want it to or not. So does that help answer that?
Yeah, it does. I don't really have any other questions.
I mostly introduce this as an opportunity for anyone who has, there are people sometimes who have family struggling with drug abuse, people who maybe even have friends or themselves. They want to talk about things. So I mostly open this up for them. Because of any place that you can talk freely about drug use and drug abuse, this is probably one of the few opportunities you'll get unless you actually go and seek out social support services or whatnot. Go to a drug rehab facility. Most people are afraid to talk about it. So, I think it's important. But cool. All right, well, from here, this wraps up a unit that I like to just casually refer to as the unit on subjective experience. It really included sensation, perception, and consciousness. How do we take in information? How do we make sense of it? And then what is that experience like to perceive the world around us? We're going to start getting away from that, and we're going to enter our last section of the class, which is about how do we have all of these abilities of learning, memory, etc., perception, are they different when we are a young child versus when we are a toddler versus when we're adolescent versus young adult versus older adult? How do these things change across time? First, we're going to go over typical development. That is, how do most people's nervous systems tend to develop? Then we'll get into atypical development, which is when we go into psychological disorders. What kinds of things can go wrong? And that's how we're going to top off the class. So from here on out, we're talking about development, both when it goes right and when it goes awry, when it goes differently than what you would expect. Human development, how does thought and behavior change across time? Therefore, this is our definition, the biological and psychological changes that occur throughout the lifespan. Therefore, we can talk about everything that we've already talked about, the biology of the nervous system, sensation and perception, learning, memory, consciousness. How do all of these things change across time? And I'm going to try and hit each of these topics as we go, but we will focus on some more than others, depending, just given the time constraints that we have. But this will be our goal. How do these things change across time? Okay, if we're going to study how psychological abilities change across the lifespan, how would you do that? How do you think we study human development? What would be your guess? How do we study human development?
Like as an experiment?
Yeah.
I guess we would kind of go by like the complexity of their thought process and tasks, how that develops. You could study that through having maybe puzzles and critical thinking questions and whatnot.
Okay, good. So we can focus on a particular ability. So that would be if we were using puzzles, we were using an intelligence test, we could actually assess their cognitive abilities, their reasoning ability. But just doing that, just giving that test doesn't really tell us how things change across time. How would we know, how would we test experimentally how something changes across time?
You'd have to follow it through across time.
Right, just follow it. If we want to know how something changes across time, there are primarily two ways that we can do that. We have what's called a longitudinal design. We have a cross-sectional design. Longitudinal design is precisely that. You're going to recruit one group of people. You're going to follow that group across time as they develop, as these psychological abilities, capacities, whatever you're testing, change with aging. With cross-sectional, it's a little bit different, where you're actually going to recruit multiple groups. And within each of those groups, people are going to be of a different age. And we're going to study them at one time. So rather than, if we think, for example, that a person's ability to solve a particular type of puzzle is going to change between when they are 6 years old, 8 years old, and 10 years old. And if we wanted to study that longitudinally, what we'd do is we'd recruit one group of children who is 6 years old. We'd test them at 6 years old, and we'd bring them in at 8 years old and test them again. Then 2 years later, we bring them in at 10 years old and test them again, and we see how their scores change across time. The cross-sectional design, what we would do is we'd recruit separately 6-year-olds, 8-year-olds, and 10-year-olds, and then give each of those groups our test, our puzzle, and see how they perform. What do you think the advantage? If you compare these two designs to one another, what do you think the advantages of a longitudinal design is? So following people across time versus recruiting different age groups at the same time.
Longitudinal, you have like a baseline of that specific person, so you know that what happens to that specific person over time, their experiences could be different than other people as they go through time.
Yes,
like
exactly.
Some people mature faster than others, mainly due to their life experiences.
Exactly, yes. The clear advantage is that you get to observe change across time. I mean, literally, if this is what we want to observe, the longitudinal design is going to be best at doing that because you're following the same people over time. Now, compared to a cross-sectional design, what this allows you to do is account for differences between people. If we thought that the ability to solve a 100-piece puzzle was different between age 6, 8, and 10. If we do that cross-sectionally, and we compare, okay, we've collected 8-year-olds, 10-year-olds, and 8-year-olds, 6-year-olds, 8-year-olds, and 10-year-olds, it could be that the difference, say let's say that the 10-year-olds are massively better than the 6-year-olds at completing this puzzle. All right? That difference could be due to one of two things. One, it could be the difference in their age group, 6-year-old versus 10-year-old, or it could be due to differences between the people within those. Those 6-year-olds and those 10-year-olds are different people. So the differences between them may have nothing to do with their age and have everything to do with who we recruited, who we put into those groups. So if you're following the same people across time, you account for what are called individual differences. Differences between people, differences in their personalities, differences in how they were brought up, differences in the genes that they inherited, et cetera, et cetera. That's the big advantage. Yes, you're observing change across time. You're controlling for differences between people. What do you think the disadvantages are of studying people in this way? Can you take a guess at that?
Which way, the longitudinal or cross-sectional?
Longitudinal.
You have a smaller study group, maybe, or it just takes more time.
It does take more time. And often you will have a smaller study group simply because it's extremely expensive, extremely time-consuming to follow a group of people across time. The biggest problem with longitudinal designs is that you have something called participant attrition. So it's expensive, costs a lot to get these people in the first place, and then potentially pay them to come back multiple times. But with participant attrition, this means they drop out of the study. So maybe you get the children when they're 6 years old, but then when they're 8 years old, they've moved somewhere else. They're no longer in the area, so you can't study them anymore. Now you really don't have any of the kind of data that you want if you lose enough participants. This is a big problem. This happens often. And so to keep them in the study, you have to pay them a lot of money usually, and that gets expensive. Plus, you need support, usually from a grant or something like that, to keep studying them across time. Yeah, go ahead.
It was just noise in the background.
Okay, gotcha. All right, so then with a cross-sectional design, why would you even do this in the first place? It's easier to collect data. Quite simply, you can't pay people, and it's possible that you can't follow them across time. So this is kind of the secondary option. The cross-sectional design is not perfect. However, if time and resources are limited, that's what most people will default to. The disadvantage, you're not accounting for those individual differences. Differences between age groups could actually be due to differences between people within those groups. And you're not accounting for something called cohort effects. Cohort effects are any similarities between people due to a shared historical event. Likewise, you could say it's differences between people due to shared historical events. A group of 6-year-olds who grow up in, say, let's say that okay, let's use a more extreme example. Do you think that your parents navigating the romantic world and navigating who to date, how soon do you have sex with someone, et cetera, et cetera, et cetera. Do you feel like 40-year-olds today had the same experiences when they were 20 as now when, I'm not sure how old you are, but when you are or were 20? Do you think that the 20-year-olds of today had the same experience as 20-year-olds 20 years ago?
Definitely not.
Definitely not. Okay. Why not?
Technology in the past 20 years just exploded. More technology, the economy's changed. Everything's changed since.
A lot has changed, yeah. Technology is a big part of it, right? Now the way that we date and we find partners, back in the day, you'd go to church, you'd go to a volunteering, or you'd volunteer somewhere, you'd meet them at school, you'd meet them at work, you'd probably have to meet them in person first. Now we have really good, well-developed online dating algorithms where you can potentially find hundreds of potential people and possibly meet up with each of them, get to know them, go on a date, and then just say, I don't want any of that. Versus if you're finding people in person, it might be that there are only a few people who are available to you. So one of the big differences between now and I think 20 years ago is the raw number of potential romantic partners that are available. People have so many choices now compared to back then. So is there a commonality between a 20-year-old today and a 20-year-old from 20 years ago? Yeah, there are probably many commonalities. It's that young adulthood, probably exploring the kinds of people who make a good partner, not yet settling potentially down on a long-term partner. But then there are these historical contexts that also shape how people interact, the kinds of experiences that people have. These are cohort effects. So cohort effects are differences or similarities between people due to historical events. If we were to do a cross-sectional study of 20-year-olds versus 40-year-olds, the difference may be due to age group. It may also be due to these cohort effects. The cross-sectional designs do not account for that.
I think a good explanation of that is like people that didn't grow up after the Twin Towers were hit, because security all around the world changed then. And another thing would be kids after COVID. Now we still don't know what's going to happen.
No, we don't.
Yeah, this is a historical event, right? Yeah, so I am curious to see how this affects things, because I think that people are probably interacting in person even less now, right? Think of the next several years when people are probably going to be, very cautious. I mean, we're already cautious about who we interact with. I don't think that's going to necessarily go away anytime soon. Even once a vaccine comes out, I'm sure there are plenty of people who will not want to get a vaccine for one reason or another. So there's still going to be that risk of you interact with the wrong person, you catch a disease. And so a lot of people may simply decide, you know what, as you grow up, you may just kind of grow up in an environment where you don't have a lot of physical contact with people. And a lot of the interactions you have with others are virtual, they're online. That's a huge cohort effect. I'm sure there are many other ways that COVID's going to affect us too. That's a really good example. I like that. Should have occurred to me to kind of bring that in, but yeah, COVID's going to be a huge cohort effect. All right. Those are our two basic designs. Well, we can get really ambitious with this too. And we can create something called a cross-sequential design, which combines the strength of both. So what you're doing here is you recruit people of different age groups and then study them across time. Just reading that, it kind of sounds redundant. It's like, well, what do you actually get from that? And I think this chart, although there are just tons of arrows all over the place, actually does a good job of describing why a cross-sequential design, if you can pull it off, is the ideal design for any kind of developmental study. So let me orient you to this a little bit. In this study, whatever they're studying here, I forget where I pulled this chart from, what exactly the data was. But here's the idea. On the x-axis, along the bottom, we have the year of testing. So this is when people were brought into the lab and tested on whenever they were tested on. Let's say that we're doing that puzzle experiment, bringing in children to do puzzles. We're testing them once in 2002, 2004, 2006. On the y-axis, we have labeled when people were born. So we have a group of people who were born in 1994 and a group of people who were born in 1996. So in 2002, we now have two groups, a group of 6-year-olds and a group of 8-year-olds. If we follow them across time, we then have those 6-year-olds turn 8 and then turn 10, and then we have the 8-year-olds turn 10 and then turn 12. So each of these arrows is going to illustrate each of the designs that we talked about in the last slide. The blue lines refer to those longitudinal comparisons. So we can see how a trait, how their ability to solve a puzzle changes across time within the same. And then we can also get cross-sectional comparisons. How do 6-year-olds compare to 8-year-olds? The unique thing that a cross-sequential design gives us is that we can now control for cohort effects. And that's what you see with the green arrows there. What we're going to have is we're going to have two groups of 8-year-olds tested on different years. So if you compare the people who were 8-year-old in 2002 with the people who were 8 years old in 2004, we can now see how much of the similarity or differences between those groups is due to the fact that one was born in 94 and one was born in 1996. How much of the differences between those 8-year-olds are due to those historical circumstances that they grew up in. Does that make sense? You follow that? I think this is it's a beautiful design. The advantage is that it does all this. The disadvantage is it's super fucking expensive.
That's what I was about to say. It looks expensive.
It's super expensive. You don't see these very often, but when you do, okay, sounds good. When you do, these studies tend to be held in very, very high regard. So you love to see these, but you don't see them very often. Okay, these are some of the research methodologies. Another bit of information we need, I think, going into this new chapter is we need to visit the debate of nature versus nurture. And you may have heard of this before. The premise is this: how much of a person's development, that is, how does their psychology, how does their biology change, really in this case their psychology, how does their psychological development change across time due to their biology, and usually the genes that they have and the various physiological processes that give rise to what your body, how your body develops, and how your nervous system and brain develops, versus how much of how a person is due to their environment, their family, or their culture, or the experiences that they encounter. So nature versus nurture. Nature refers to biology, nurture refers to environment. Well, I'll start by saying this. This is actually a dead debate. Nature versus nurture, not really debate anymore. It doesn't exist anymore. What we do know is that both contribute. We actually have good evidence that there is a genetic component and an environmental component to every single psychological trait that you have. We can talk about your personality. We can talk about your intelligence, your how you reason, some of your moral values. Each of these seem to have a genetic and an environmental component. So the debate, the new debate, is not nature versus nurture, but simply how much is due to nature and how much is due to nurture. Because across these different traits, sometimes nature factors in more, your genes matter more, and in other cases, nurture matters more, the environment matters more. For example, I don't know if you, Savannah, or anyone listening to this realizes, but intelligence, the capacity to adapt to change, is heavily genetically controlled. We know that so how people talk about the contribution of nature is how heritable is a trait. And what that really means is if you were to measure everyone's intelligence and then examine how much variation exists between people, we can say what percentage of that variation between people is due to their genes versus their nature. And about 80%, the estimates kind of vary depending on which study you're looking at, about between 60 and 80% of a person's intelligence seems to be or differences between people in intelligence is attributable to differences in their genes, which is not something that I think most people realize. And I think it surprised me when I started into this as well. So intelligence is a heavily genetically controlled trait.
And then you got to debate what kind of intelligence.
True. And there's an argument to be had of there are many different types of intelligence, but there's also based on what I've seen and the arguments that I've seen for multiple intelligences versus a unitary intelligence, I actually think that there is better evidence for what's called the G factor of intelligence, which refers to a unitary intelligence. That is, yes, you can be more visually inclined or kinesthetically inclined, or you can be a better, art intelligence versus mathematical intelligence. But underlying each of those abilities, there is this common factor that makes each of those intelligences better. So you might say have a better mathematical reasoning than art reasoning, but if you have a higher G factor of intelligence, both of those are relatively higher, even if one is still higher than the other. Does that make sense?
Yes.
So there are different capacities, and people are better at certain things than others. But there's also a unitary G factor of intelligence, it's called.
And the next question is like, what part of intelligence is like stronger intelligence dominant or recessive traits and all that?
True. Yeah, we'll actually talk about that a little bit. Intelligence is polygenic, so it has many different genes contributing to it. And I actually don't know whether there's any kind of dominant recessive pattern within intelligence. You know how sometimes there can be incomplete dominance and co-dominance. I actually think a lot of genes responsible for intelligence tend to be incomplete dominance, where you have some amount of influence of a dominant gene, but then it's kind of mixed with the aspects of the recessive gene as well. More of a continuum. So the genes kind of intelligence is going to exist more on a continuum. So you see how the genes influence one another tend to be on more on a continuum than this or that. You're not intelligent or not intelligent. You're more of there's a gradation in between. Those are good questions, though. I mean, this is we can talk about this subject for. You can have an entire class on intelligence, and I highly recommend it. Intelligence is a very good thing to know about and to study. I think it'll to understand your own intelligence, I think can actually improve it to some degree. It's not that intelligence is not influenced by environment, because it most certainly is, but a lot of it seems to be controlled by genes. So how can we study this? I mean, I'm making very strong claims here. We know how much of something is due to genes versus environment, or that every single trait that we can conceive of has some genetic versus some environmental component. How do you think we would study this? How do we know this information? How would you study whether something is due to someone's genes versus their environment?
You would have to have basically people that have been in the same environment their whole lives, do comparison tests and whatnot.
Okay, that's one part of the puzzle. Maybe they share an environment versus they don't share an environment. We also have to account for what?
Genetics.
Genes. And whether they share genes or not. Turns out how you can do this in a fairly robust way is you use identical twins. Identical twins, monozygotic twins, twins that you have a sperm and egg meet, they create one cell, and then that one cell completely splits apart, and you get two copies of the same individual. They share 100% of their genes. So they've done this. They've taken identical twins and they've run them through different studies where sometimes the identical twins are raised in the same household. Sometimes they're raised in different households. There are all the kinds of stories of identical twins being adopted out to different households, and then seeing how similar they are versus how different they are. What you can conclude is that any differences that you observe between two identical twins must be due to environment. That's the beauty of a twin study. So I have a video here. I realize that you probably have to go, Savannah. What I'm going to do is I'm going to put this up. Feel free to leave if you need to leave. But this is a good study. This is a good video that introduces just how much genes can contribute to the similarities between people and to the traits that we think are probably due to weird environmental circumstances. So I'm going to put this on. I'll record it, and then I'll see you later, Savannah. All right, so let me get this video out. Let me stop this and share this. All right, here we go.
Let's talk about twins. Twins turn heads wherever they go. Seeing two identical infants, children, or adults is irresistible, causing us to peer into baby carriages, stare into playgrounds, and even ask rather personal questions such as who is older, who is smarter, who decides what both of you will do, as if everything twins do is exactly the same. Society tells us that we all differ in appearance and behavior. So when we encounter two people who look and act so much alike, it challenges our belief in the way that the world works. We find ourselves intrigued and drawn into twins' lives, trying to understand them. For most of human history, psychologists believe that we're largely products of our environment. The twin research is teaching us that so many more of our behaviors than we ever would have imagined are influenced by the genes. There are two kinds of twins, identical and fraternal, and both are essential in twin research. Identical twins result when a single fertilized egg divides within the first 14 days after conception, and these twins share all their genes in common. Fraternal twins share half their genes on average, just like ordinary brothers and sisters, and they result when a woman releases two eggs at the same time, separately fertilized by two separate sperm. We can compare the similarity of identical twins in running speed or in how fast they solve math problems to the similarity of fraternal twins. And if identical twins are more alike, and they usually are, this tells us the genes play an important role. And most studies use identical twins raised together. Studying the rare pairs of identical twins reared apart is even better, because if identical twins raised apart are as alike as identical twins raised together, this is even more compelling evidence that genes are important in our development. Think about the identical Jim twins, Jim Lewis and Jim Springer, who grew up in different Ohio cities. They didn't meet until they were nearly 40. And they discovered that both twins hit their fingernails down to the nub. They both drove light blue Chevrolets. They both had mixed headache syndromes beginning in their teenage years. And they both liked to vacation on the same 3-block strip of beach in Florida. Jim twins also both named their sons James Allen. Now, James is a fairly common first name, but Allen is a much less common first or second name. Both of the twins had worked part-time in sheriff's offices and part-time at McDonald's. And they loved to scatter love letters around the house for their wives. And in a curious twist, both twins had married women named Linda, divorced them and married women named Betty. But then one of the Jim twins divorced Betty and married Sandy. You know that divorce is a partly genetically influenced trait, so you can imagine the worry on the part of the remaining Betty. Now, what about the twins Jack and Oscar? They had dramatically different environments, but even that did not prevent them from amassing a whole list of similarities that surpassed even those of the Jim twins. Jack was raised Jewish by his father in Trinidad, and Oscar was raised Catholic by his grandmother in Nazi Germany. And when they met for the first time, they discovered that both twins liked to wear rubber bands around their wrists. They thought it was funny to sneeze loudly in elevators. They both washed their hands before and after using the toilet. They both read books from back to front. And they hated floral centerpieces because they said it blocked the view of the person seated across the table. How do we explain these similarities? Well, it could be that reading books from back to front suggests impatience, or sneezing loudly in an elevator is a cry for attention. But regardless, the fact that we see these similarities repeated in identical twins, so much more than fraternal twins, tells us that genes do play a role. Dorothy and Bridget, reared apart twins in Great Britain. They show us that you don't have to live with somebody to be like them. You only have to share their genes. When they met for the first time as adults, both twins were wearing 7 rings, 3 bracelets, and a watch. And the similarities did not stop there. The twins described themselves as short-tempered, disciplined, and strict. They liked the same brand of perfume, they liked the same kinds of books. They had worn nearly identical dresses to their weddings and carried nearly identical floral bouquets. They remind me of the identical reared apart twins, Mark and Jerry. Mark and Jerry grew up in different cities in New Jersey, and they didn't meet until they were in their early 30s. They were both volunteer firefighters, but their signature quirk was holding a can of Budweiser beer with a pinky finger underneath. And you can see that they also carried huge key rings. They attached to their belts. Belts had huge buckles on them. They both drew their heads back sharply when they laughed. They were 6'4", bald, and heavily mustached. When I took them out to dinner, I discovered they had a shared passion for Chinese food and for steak served extremely rare. I also studied Barbara and Daphne, the Giggle twins. My colleagues and I affectionately call them that because when they met for the first time, they discovered that they laughed uncontrollably with each other and with nobody else. And And they had the same crooked pinky fingers, the same disinterest in politics, and they drank their coffee cold, black, and without sugar. These twins had had a first miscarriage in their first pregnancy, followed by 2 healthy boys and a daughter. That may not be so surprising, because female physiology may in fact the sex of our children. In this case, physiology was perfectly matched. Shortly after they met, they concocted a drink called Twin Sin. It was made of vodka, blue curacao, creme de cacao, and cream. My colleagues and I thought it was a little curious, but the twins thought it was just delicious. I finally want to mention 2 sets of identical twins, males, born in Colombia, South America. 1 pair from the city, 1 pair from the country. We don't know how this happened. Early on in the premature nursery, 1 newborn twin was accidentally exchanged with 1 newborn twin in the other pair. So these 2 sets of brothers grew up thinking they were fraternal twins. In fact, they were completely genetically unrelated. When they were 25, the truth was discovered, and the real pairs were reunited. I went down to Bogota to study them, and I discovered that the personalities of the reunited twins aligned almost perfectly. In one case, the twins were outgoing, gregarious, risk-taking. And in the other case, they were introverted, a little cautious, a little restrained. Again, we don't fully understand the reasons behind these similarities, but seeing them repeated in identical twins, more so than fraternal twins, gives us a genetic perspective on human development. And we need to think seriously about these findings because they have huge implications for how we raise our children and how we can all make the best of our abilities, our goals, and our dreams. In my experience, parents of 1 child are environmentalists, and parents of 2 children are geneticists. And I say that because parents of 2 children realize rather quickly that what works for 1 child doesn't work for the other. And that's because children come into the world with their own genetic predispositions that lead them towards certain activities and places and opportunities. Parents have to have realistic expectations about each child. 2 dancing parents may not have a dancing child, because even though each parent shares half their genes with the child, genes get reshuffled in each generation. You know, I tell parents, you don't really bring up your children, they bring you up. Because each child evokes certain treatments and certain responses from each of their parents. A child with athletic abilities should be given opportunities to play sports. An artistic child should be given opportunities to paint and to draw. And a shy child should be given opportunities to speak up more, encouraged gently to do so. In this way, parents can make a huge difference in the lives of their children. And I also want to acknowledge the teachers and the mentors and the managers who work so closely with twins and others and affect their lives. As a psychology professor, I identified a very promising undergraduate student, one who showed real ability, talent, and drive. He was the first in his family to go to college, and he lacked guidance and opportunity. I work with this student on a number of projects, and today he's an advanced graduate student at the prestigious University of Michigan. Back to our twins. Twins are not just mere objects of fascination. Just by being themselves, just by acting naturally, gives science a powerful tool for understanding genetic and environmental influences on behavior. And in this way, they tell us about our humanity, why we are the way that we are, and how we got that way. Thank you.
All right. So I think that's kind of a powerful introduction to the rest of the chapter. I think, again, it's important to recognize that that both our genes and our environment contribute to how we end up developing. So in this week, we're going to focus on the nature aspect of things largely. We're going to talk about DNA and how DNA ultimately translates into development of our nervous system and other aspects of our body that influence our psychology. And then we'll begin a kind of tour of prenatal development, what kinds of things happen before birth, and that will transition into next week's topic on what happens after birth. What kinds of environmental influences will then take what DNA has set up and further shape and refine it. All right. Well, since I'm now talking to an empty room, I will call it here. If anyone has questions, if anyone has concerns, you know how to find me, and I will see you next week.